Some more about quadratic functions today, mainly minimum maximums. So quick little reminder, the x-coordinate of your vertex, if your quadratic is in standard form, is negative b over 2a. Quadratic functions are either going to have a minimum value or a maximum value, depending on whether they open up or down. So if you think about a quadratic function, a parabola that opens upwards, say that it has a vertex of 2, 4. That means it has a lowest y value that it reaches, and that lowest y value on that one I just drew is the y value of 4. If you have one that opens downwards, say it's got that same vertex, then that means that y value of 4 is the largest or the maximum value of my output. Now you can tell if it's a minimum or maximum without graphing. If you think about your leading coefficient, if it's positive, then that's stretching upwards. If it's negative, then it's reflected across the x-axis and opens down. We can find a maximum minimum value without graphing. To start with, let's look at our leading coefficient. That's a positive 8/5, so my graph is going to open upwards, which means this will be a minimum value. I need to figure out what y-coordinate or what minimum value it actually reaches. So let's find our vertex, because it's always going to happen there. So if I do x equals negative b over 2a and plug in my values for a and b, I'm going to end up with 4 over, if I multiply that, that'd be 16 over 5. I could multiply by the reciprocal and end up with, after I reduce, 5 over 4. So that's the x value of my vertex. My maximum minimum is the largest or smallest output, so I need to find my y value. Plug 5/4 back in, you get 2.5. So this one has a minimum value of 2.5, specifically when it's at the x value of 5/4. Let's do another one. Actually, I'm going to change this one because we just did one in standard form. Let's do one in vertex form. So, okay, I'll just make one up. Let's do negative 2w minus 4 quantity squared plus 52. Okay, so thinking about whether this would be a maximum or a minimum value, it's going to happen at my vertex. So my vertex is 452. Since I have that negative 2 out in front, this is going to open downwards, which means that it has a maximum or highest value of 52. Let's think about a little situation involving a projectile. So you've got this ball thrown up from 100 feet in the air, must be standing on top of a tall building and tossing it, math problems, and it's got an initial velocity of 80 feet per second. We are given a function that gives us the height of any projectile, and to make it specific to our situation, we have to plug in our initial velocity, v sub 0, and our initial height. So I'll be replacing v sub 0 with 80 and s sub 0 with 100. Okay, so if I'm doing my equation that models my ball's height in this specific situation, I just have negative 16t squared plus 80t plus 100. And now on b, I'm looking for after how many seconds does my projectile reach its maximum height. So there's my path of my ball right there. I'm looking for how long it takes it to reach that vertex in the middle. So I'm looking for my value of t that occurs at my vertex. So instead of x equals negative b over 2a, I'm going to do t equals negative b over 2a because I just have a different variable I'm using. If I plug in my values for a and b, I'm going to end up with 80 over 32, which is going to give me 2.5 seconds. So it reaches its maximum height after 2.5 seconds, and then if I want that maximum height, I need to plug 2.5 into my function. So if I plug 2.5 seconds into my function that I wrote in part A, I'm going to end up with 200 feet as my maximum height. This one, I'm looking for two integers whose difference is 10 and product is the smallest value possible. So let's think about, say my first number is x. If they're going to have a difference of 10, that means they need to be 10 apart. So I can make my second integer something like x plus 10, because if I was to subtract those two, one's 10 bigger than the other. Now I'm looking for the specific numbers that have the smallest product possible in this situation. So the product of these two numbers is x times x plus 10. I know that the minimum value for this function is going to happen at my vertex. So I'm going to multiply those together so I can actually find my vertex. Okay, now it's in standard form, so I'll do x equals negative b over 2a, plugging in 10 for b and 1 for a. So I get x equals negative 5. So that's my first number. My second number is x plus 10, so negative 5 plus 10 gives me positive 5. So those are the two x values that minimize this function, 5 and negative 5. This one didn't ask what the minimum product is. The minimum product would be negative 25 if I multiplied those together.